A very good morning to all of you, my dear students. Today we are going to explore the concept of light a little further. Let's first of all, let's see how an image is formed of two types. First, a point size. If a point size object is being placed in front of a mirror, how its image is formed, how light is really traveling and forming that image, okay, after reflection. And then we will see that how an image is formed by a large size object. Okay, so let's continue. Okay, so just like our previous class, we have a source of light there to generate some light. Then we have a passage. Then we have that cloth to keep it on place. Then a sheet, marker, and a ruler to draw the rays. A pen and a box to demonstrate as images. A mirror, and here we will see it. Okay, so without wasting any time, let us start. First of all, we will draw the ray diagram of a plane point size object. Let's see how it works. Let's see, this is our point size object and we kept it here. So we can see that how light is going from here to the mirror, can't we? So let us draw this. This is our scale. First let us put this point where it is. This is our object. From here we can see that light is traveling through here and here. Are we good? Yes. Okay, now let's join these lines. So this is our direction of light from which it is passing. Now let's move one step further and see it. Let me put this camera below so that you can also see it clearly how it is coming to us. Okay, so our first incident ray went here. Okay, and this is our object. This is our object. So as we can see that our object is clearly visible in the mirror, isn't it? It is clearly visible and it is coming directly towards us. So we will track that line back to the camera of this phone. Okay. Let me keep it here so that I can clearly make the adjustments correct. Okay, this is it. Straight it is coming towards the camera right here. Let's bring it a little bit closer. Is it good? No. Yeah, now it's good. Let us bring this ray here. Okay, then the second ray also. Okay, so similar size image is formed here. Now you can, okay, that little bit line is tilted in between because of the up and low here, but it's okay. We can understand the concept. Now let's see if it is drawn correct or not. It is kept here and the image is, so-called image is formed here. I'm not sure you are able to see or not, but if you will see that black reflection which is forming there in the mirror, you will notice that it is exactly in between these two lines, and from here you will see that light is traveling with that line, and then the reflection is traveling from this line and reaching to us. I hope you understood this. Now let's try this with a bigger object. Okay, so now this is our object, and we can draw this line easily. Okay, and from here till here we can also draw one line. Okay, so this is our objects line, incident rays. These are our incident rays. Okay, and now let's draw the reflected ray. Okay, so reflected ray is coming from here directly towards us. And one more from here. Okay, so this was our image. Let's say this is our image, sorry, object. This is our object, and here on this plane here we get our image. Okay, this is image, this is object. So what we understood, that in every plane mirror the object, the image is almost exactly the same size as the object. Okay, and incident ray and reflected ray are equal, this though we know. And then one more interesting feature is there, that on every plane mirror there is a lateral inversion. Okay, let's say if you will see it from here, we will find out that something is written here on the left side, but in the image you can see it on the right side. Okay, that's on the right side of image, but here it is not, here right side is not there. Similar things we do. Let's say if I am placing my right hand here, in the image you will see that this is my left hand, but it's actually my right hand. Okay, so this thing, my dear students, is known as lateral inversion, in which one side, this side is left, this side is right, but if you will see in the mirror you will find out that this side is right and this side is left. This is lateral inversion. And one more interesting thing is there, third thing, that if you will keep it here and we will see it from here, then you will find out that the size of the object is exactly same as the size of the image. Okay, there are these three features of a plane mirror. Okay, so I hope you understood that concept. This is the ray diagram of a point size image, and this one is the ray diagram of a large image. You can take a screenshot and you can for future further references. Okay, so now let us see a few uses of plane mirrors. They are used in makeups, used for makeups in makeup mirrors or a looking glass. This though we know, we have a mirror in our dressing tables, in front of our basins, and other places, looking glasses, where we look, see our face. Okay, they are used in barber shops. Whenever we go to barber for shaving or haircut, there is a mirror in front of us and also in back of us. Okay, and somebody asked me that, sir, why we see a lot of images there? Because every time those two mirrors are placed in front of each other, okay, but they are not exactly parallel to each other. This is the tricky part. They are never exactly parallel. If they are exactly parallel, you will not be able to see what's behind you in the mirror, because the image will be formed just behind you. They are little bit like this, okay, like this they are placed, so that reflections are going that way or that way, okay, to let you see what's behind. So that is a very interesting thing. You can check it by yourself. When two plane mirrors are kept on the opposite walls of a room, they make the room look spacious. Okay, this is also true. When two plane mirrors are kept on both end of the room, this side also you will see it will look very far away, and this way also very far away. So it looks very big room. Okay, this is a very tricky part. Shopkeepers can use this in their shops. If they have two parallel walls which have nothing, they can place mirrors so that their shop will look very big. They are used in laboratories, obviously. Laboratories mirrors are used. They are used in solar cookers and solar geysers. In solar cookers, we understood that mirrors are placed all around so that light is as much light can be reflected to the food. They are designed in such a way that the maximum number of light is reflected to the food, okay, to be cooked faster. And same thing with solar geysers also. Then they are used to make periscope and kaleidoscope. This is a periscope in which light enters from top, then gets reflected, comes down to the lower mirror, and then comes out so that we can see what's above us. Okay, this is generally used in submarines, and military also uses it, and other ways also. If let's suppose some drainage issue happened, underground problem happened, and we'll have need to have a look what's going there, so we can use a periscope. Kaleidoscope is looks like this, and it is a very beautiful thing to have a look. I had one kaleidoscope, but I found it, but it was not there when we were kids. We were having one kaleidoscope, but now it's gone. It's long ago. So I have shown you this image so that you can relate. Okay, then we have speed of light. Speed of light, my dear students, in vacuum it's 3 into 10 to the power 8 meter per second. Okay, 3 lakhs kilometer per second. This is fixed, 3 into 10 to the power 8 meter per second, the speed of light. This is very interesting that in the whole universe there is nothing which can travel faster than the speed of light in vacuum. Okay, nothing. So this is sometimes referred as the speed of the universe, or some scientists have other many different types of theories related to it. But the fact is that nothing can travel faster than the speed of light. If anything travels according to Einstein's uh, theory of relativity, it says that if we design something or we make something which can move faster than the speed of light, then that thing will travel in time. Okay, then that thing will become a time machine itself. How, why, we don't need to understand right now, but if you are curious enough, you can search it on YouTube. You will find some good resources there. Okay, then there is refractive index. Whenever light travels with something transparent but denser than vacuum, the speed of light is reduced. Let's say in air also it is little bit reduced, almost it is same, but little bit difference is there. In glass it is considerably reduced, in water it is considerably reduced. So these, the ratio in which the speed of light decreases is known as refractive index. Let's say in your books it is given that the speed of light in glass is 2 into 10 to the power 8 meter per second. That means 1 into 10 to the power 8 meter per second the speed of light is reduced. Considerable change. Then in water it is 2.25 into 10 to the power 8 meter per second. That means 0.75 to 10 to the power 8 meter per second it is reduced. So it is considerably reduced in these things. So this is refractive index. To find refractive index, we can divide the speed of light in vacuum by the speed of light in that medium. Okay, and then we have colors, primary colors and secondary colors. Colors thing is being removed from the uh, syllabus, reduced syllabus, but we can have a look bit that there are three basic colors, primary colors: red, blue, and green. Okay, that's why LEDs are also having these colors. These are primary colors. Okay, and whenever we will mix red and green, this much though you have seen in your childhood also, that if you will mix red color and green color, you will find what? Yellow color. Okay. Similarly, if you will mix blue and red, it will become something pinkish like magenta. And if blue and green is mixed, sky blue type of color is formed. And if we mix all three colors, then we will get white color. Okay, this is a very well known fact that you know how this thing was proved. First of all, that light is made up of 7 colors. A scientist, I don't remember his name right now, but he did one very good great experiment. He painted a circular sheet of paper in all the 7 colors. Okay, let's say green, yellow, blue, orange, all the 7 colors: violet, indigo, blue, green, yellow, and red. Okay, so he painted 7 colors, and then he spun the wheel very fastly. Then what happened? The people, the audience who were observing that experiment, they saw only white color on that board. Then he explained that how these 7 colors mixed together when it was spinning very fastly, and the light got mixed in our eye, and it so we can see white color only. So this is it. This is the main thing. And then there are some basic formulas that is asking that if we will subtract red from white, what we will get. If we will subtract yellow from uh, white, what we will get. Okay, so these things you can have a look. It is not very complex. If you will read simply once, you will get it. Okay, now we have formation of rainbow. Rainbow is formed by the same concept. Okay, dispersion of light. Okay. Total internal reflection, here it is being done. Okay, it says that a rainbow is a natural band of colors formed in the atmosphere just after the rain. This though we know. In the sky comes out. If the sun comes out, a rainbow can be seen in the sky. Just after the rain, if the sun comes out, rainbow can be seen. And rainbow is formed always opposite to the direction of sun. What happens is the sun gives light is coming from sun, and air droplets are still present in the atmosphere. Those droplets, just like you can see in this image on your book, page number 58, just like it gets inside that droplet and reflected and disperses into 7 colors, and then comes back towards us, so that we can see a rainbow in front of us. Just if the sun is behind us, we can see rainbow in front of us. This is how rainbow is formed. The dispersion of light and reflection of light is not given in complete details. I think it will be there in the higher classes, so we will not discuss how light is dispersed. uh, if you are curious enough, I can tell you one thing about it, that all the 7 colors of light have different speed. Actually, they have different wavelength, but you can understand simply by that they are traveling with different speeds. Okay, so when a denser medium comes, as we saw that the speed of light reduces, so it acts separately for all the colors. Okay, it is not exactly the case, but I am just trying to make some sense that there is something happening there. There are different in terms of speed or wavelength or something like that. That's why they get separated in certain conditions. The speed of light, the 7 colors, okay, they have something different. That's why they get separated in certain conditions. That's why they get separated, and then once they get separated, we can see them separately. Okay, this is it. This is how rainbow is formed. Okay, and one more thing is that if my shirt is looking blue, that means blue and white, that means it is absorbing almost all the colors except blue. which color is being, if this wall is looking purple, that means it is absorbing all the colors except for this one. This one it is reflecting, that's why it is looking blue. Plants look green, why? Because they absorb all the colors except green. Photosynthesis is maximum in case of red light. Okay, so they absorb all the color, red and blue they absorb, but green they reflect. They don't need green, that's why we see them as green. Okay, this is very interesting. If something is white, that means it is reflecting all the colors at equally, all the colors that it is reflecting equally. If something is black, that means it is absorbing most of the colors. Okay, inside it only some light is coming out, otherwise most of the light is being absorbed. Okay, that's why black color is more hot and white color is cold. Okay, um, in winters we used to wear black color, why? Because it will absorb a lot of light and it will give us heat. In summer days, in a very sunny day, if you will wear a black shirt and go out, you will sweat more than the person who is wearing a white shirt. Why? Because black is absorbing more energy. Okay, and white is reflecting all of them. So this is it, this much is there in this chapter. If you have any doubt regarding anything, I have tried my best to explain the things to you, although we are not sitting together so that we can interact completely, but still I have tried my best. And if there is anything I don't know I told you this that day or not, but I will tell you again. Ambulance, if you will see, this is lateral inversion. Anyway, if you will see ambulance next time, just focus, have a look, pay attention on what is written on in front of it. Okay, it is written opposite. Ambulance is written there, but it is always written opposite, so that once when you will see it in your mirror, on the rear view mirror of your car or bus, it will look like it. You can simply read ambulance. Other things you can't read. If I will show you this book here, although these cameras can rotate the things, but if you will take the book and stand up in front of your mirror and try to read it, you will not be able to read it because things will be in reverse order. Okay, that's why in ambulances it is written in reverse order so that you can read it perfectly in front of you. This is lateral inversion. Rest, I think everything is being dealt. Okay, so this much is enough. If you have any doubts or confusions regarding it, which we can talk and sort out, please let me know, and then we will discuss them. And if a certain area or certain concept I will feel that it is not being clearly conveyed or not understood, then I will make one more video on this topic. Okay, thank you very much.